Okay, you're going to start today by going through this graph sheet. So for each h of x, highlight on the graphs the pieces described by the given domain restrictions. So if you look at number 1, we have two graphs. We have f of x as negative 1/2 x, and we have g of x as x. Graphs are shown, and h of x is saying, well, you're going to have this negative 1/2 x, but this is only going to be where x is less than or equal to 0. So this is what we call a domain restriction, because we're not going to deal with the whole graph. We just want it where x is less than or equal to 0. So I can come to my first graph here, my negative 1/2 x, and I want everything on the line where x is less than 0. So here is x is 0 down the middle here. I want less than, so that would be all my negative numbers on the left. So that would just be everything there. And my next piece says we want equation x if x is greater than 0. So here's x is 0 again. If I want greater than 0, I want everything on the right side here. And that was what we were looking at. Cool. Okay, number 2. F of x equals 1/3 x squared, and g of x is x. Now, equation h of x says x if x is less than or equal to negative 1. Ooh, we're dealing with x, which is over here. So we're actually dealing with the right graph first. Ooh, sneaky. And it's if x is less than or equal to negative 1. So here's negative 1. Less than that would be everything to the left of it. So we just want that piece there. And we're going to choose 1/3 x for everywhere that x is greater than 2. So over here, here's where x is 2. If I want greater than, I want the right side of it. Cool, cool, cool. Number 3, we have f of x as negative quantity x plus 1 squared plus 4, and g of x is negative absolute value of x minus 2 plus 3. And it looks like our first part of h of x is negative x plus 1 squared plus 4. So that's our left graph. If x is less than 2. So let's see, x is 2 right here. If I want less than, that's everything to the left of it. So it looks like this time we're actually going to highlight the whole thing. That was exciting. And for the right side, with our absolute value equation, we want x is greater than or equal to 2. So here's 2 again. And we want everything greater or equal to that, so that's going to be all that side there. You might be wondering about, what about less than versus less than or equal to? Well, that would just be, are we for sure including that point, yes or no, in that? And now we get a fun one with 3 equations. So we have a linear, a quadratic, and an absolute value. Our first part of this function, h of x, is negative the absolute value equation where x is less than negative 2. So here's negative 2. I want everything less than that, so that's going to be everything on the left. The next piece would be my 1/3 x squared, so my quadratic. If, let's see, how would we read this part? All of this. When it says negative 2 less than or equal to x less than or equal to 3, honestly, here's how I think about it. X is between negative 2 and 3. So I can go to negative 2, I go to 3, and now I'm highlighting everything in between that. And my last equation is just x if x is greater than 3. So here's x is 3, and I want everything greater than that, which is going to be everything on the right side. Okay, so that's just highlighting pieces. You might be wondering, well, what's the point of that? Okay, This activity is called Frankengraph, and the reason for that, Frankenstein, we're pulling all these pieces from different body parts, which is disgusting, and sewing them together. Well, we're going to do the same thing with a graph, and all of these are called piecewise functions. And piecewise just means we're taking pieces of different graphs. And so we're going to look back at number 1, where this equation is what we saw in number 1. So let's go back. And what we're going to do, this is like taking our highlighted portions of the graph and we're going to place them on the same graph. So I'll take the left side of the first, the right side of the second, and bring them together and mush them together. Here's what that looks like. If I could just cut this out on this image here, I would, but I can't, so I actually cropped them earlier. So this was number 1. I wrote that in the corner right there, down here on the left. And what we're going to do is we're just going to place that here on this graph. This was -1/2 x if x is less than or equal to 0. That's what that graph represents. And then I can take the second half of that equation. Here I also wrote number 1 in the corner there. And we're going to take it and place it on this other side. Get them to line up like that. And this side is x if x is greater than 0. And we chopped it right down the middle and we pasted those two on the same graph. And that is what a piecewise function does. It takes pieces and puts them on the same graph. So I can look at number 2. Okay, here is my piece for number 2. And it looks like this is everything that was less than -1, so this is the x equation. Sorry, a little technical difficulty. Resize that ever so slightly so it actually fits on here. You get the point, hopefully. It's not perfect, but neither is life, and that's okay. I just want to move this around, for heaven's sakes. That's as best as I can do. Maybe. Haha, got it. Okay, so that's where x was -1. We cut it right here, and we pasted that section of graph. And now we're going to go grab our quadratic from number 2. And this is where x was greater than or equal to 2. That one went much smoother. Close enough, right? And that would be our piecewise function for number 2. We do have a gap in the middle, and that's okay because the function was not defined for those points. At this time, I want to talk about the difference between the less than or equal to versus just a less than or greater than. How I'd represent this on a graph, if it's less than or equal to -1, I'm going to put a point here to represent yes, it does for sure hit. But for x greater than 2, since this doesn't actually hit 2, we're actually going to put an open circle on 2 and then let the graph continue forward. So if it's less than or equal to or greater than or equal to, it's going to be a closed point, kind of like inequalities, because this is an inequality. Duh. This one's going to be an open point. Okay, go to number 3. Let's see, we're less than or equal to 2 for this one. There we go. Already drew in my boundary on that one. So that was this little fellow right there for the less than 2. And because it's just less than, we would have an open circle here. And now for the second half, this would be for x greater than or equal to 2. Nice. And for this one, because it's or equal to, I'm going to have a closed point here on that one. So it's open circle for the left side and closed point on the right side. And that would be our piecewise graph for that one. Number 4, we get the fun one with 3 different sections. Okay. Let's see, this piece was x if x is greater than 3. Then we have the middle section, the quadratic between -2 and 3. And I hope you guys are cutting these because that's going to be so much easier than what I'm doing. It's so close to being perfect. No, it's fine. Okay, you know what, not worth my time. It's fine. Okay. There, we'll just do that. It's fine. Those are connected. And then we have our last piece. Once again, good enough. Okay, so for this one, we go through and now we'll just add the closed first open points. First one, this one's going to be open for that piece. Our middle piece, it's closed on both. And for our last one, that's open, but since they overlap, it's already closed, so it's fine. Because how would I put an open circle around a closed circle? The closed would just fill in the open. And so we'd be good to go there. So this is just the conceptual piece of like what is a piecewise function, what's happening. We're going to get into the specifics of graphing them now. I just wanted you to see that. So for example, if I go to graph like part A over here, I'm always going to look at this domain piece first, and I just always kind of draw in my boundaries. Boundaries are a good thing, people. Always. Anyway, yeah, mental health, boundaries, woohoo. Okay, so here's how I kind of think about graphing them. Now that I kind of know conceptually what's happening, I see that x plus 1 is happening on the left side. I'm actually going to call this just sections 1 and 2. Section 1, section 2. And I want to write that a little bit clearer. Section 1, section 2. And x less than 2 for that first section would be everything over here. Section 2 is over on the right. I'm labeling them just for our purposes here. I'm going to go ahead and graph x plus 1 on the left side. So my y-intercept, you know me and my color coding, is 1, and then my slope is up 1 over 1. That looks like a negative. There we go. 1. When I get to this boundary, I see it's just less than, so I leave it open, and I can keep going in the other direction until you have enough to get your graph shape. That's fine. And the right side is negative x minus 2. So I could go to graph this. You're like, wait a second, Miss Lambert, you're in section 1. That's fine. I'm going to erase it. I just needed it to give me the rest of my points. Here's where I'm actually going to start, is this boundary, and it's greater than or equal to, so I get to put a point here, and then I keep following that slope, and we'll just connect from the boundary forward. And now I just erase anything I used in there, and voila, we have our piecewise function. We're going to do another example now. We'll do part B. Maybe we'll do one of these. And we'll get to those in a second. Let's do part B. So my boundaries here are at anything in here. So I'm going to look at negative 3 to 5. 1, 2, 3, 4, 5. And then the second piece is 5 to 9. 1, 2, 3, 4. All right, and in here we have sections 1 and 2. 1 is between negative 3 and 5. 2 is in between here. So if I go to graph this first piece at x minus 2, my y-intercept is at negative 2, and my slope is positive 1. Up 1 over 1, up 1 over 1. When I get to 5, it's just greater than, so it's going to be open. When I go back down to negative 3, it's or equal to, so that one will be closed. And then for 6, the reason I want to do this one is because I just want to remind you what just y equals 6 looks like. That's just going to be at y equals 6. 1, 2, 3, 4, 5, 6. And so I could just connect this. This one's closed. This one's open. Connect that, and then you can just erase what you don't need. Beautiful. Okay, let's do just one more. Let's get quadratic and absolute value. Maybe we'll do one with 3. That makes it more fun. So let's do part E over here. Okay, here's my restricted domain. We're at negative 2. And we're at positive 2. And those are the only numbers that show up there. Sections 1, 2, and 3 correspond. Let's see, x less than negative 2 is over here. Everything in the middle, and then everything on the right side. Okay, I'm going to start with 2x plus 4. My vertex is at -4, 0. 1, 2, 3, 4. Great, my A value is 1, so I'm going to follow the 1A, 3A, 5A to just get 1, 3, 5. For 1, up 1, for 1, 2, 3. 1, 2, 3, 4, 5. And that's great. But I gotta go the other way. So go over 1, up 1, over 1, up 3. I get to the boundary. This one's gonna be open since it's just that less than. And there's my parabola. Okay, now we'll go to the second equation here. I got 3 times the absolute value of x plus 2. My vertex on that one is 0, 2. So 0, 2 is here. And then since my A value is 3, remember with the absolute value, that's just a slope in either direction. So I'm going to go up 3 over 1, 3, 2, 3 over 1. And this one is going to be closed on both sides. So up 3 over 1, up 3 over 1. And then my last section, 1, 2, 3, has a y-intercept right there. And it's just down 1 over 1. This one is just going to be open at the boundary. And then we keep following that slope of -1. And we got it. I'm going to see if I can delicately erase. Well, it kind of worked. But you get the point. I'll go draw that back in. And that's how we graph piecewise. So I think once you understand conceptually what's going on, it's not terrible. The last thing I just want to cover is how to evaluate these functions. So let's look at part B here. Yep. To evaluate, well, if I want to find first f of 3, this notations means we plug it in, but you got to find which equation it fits into, or I guess which piece of the function it fits into. So the first one, f of 3, well, 3, I see it show up twice, so how do I know which one it's in? Well, this one is less than or equal to 3, and so since this is 3, we're going to plug it into x minus 1. So we get 3 minus 1, which is 2. Whoop-de-doo. Okay, f of 0, once again we're going to find out where does 0 fit. Is 0 between -5 and -1? No, it is not. Is 0 between -1 and 3? Yes. So it's also going to come into this equation here. 0 minus 1, which is -1. Okay, we go to -4. I just go through. Is -4 between -5 and -1? Yes. So we're going to plug into that piece. -4 plus 1 squared. It's -3 squared, which is 9. And for 18, is 18 between -5 and -1? No. Is it between -1 and 3? No. Is it greater than 3? Yes. So I'm going to go 2 times the absolute value of 18, which that's just 2 times 18, which is 36. If okay, so if your x value is not defined in the domain, the function is undefined at that point. Here's what I mean by that. I'm going to give you another example. Let's say I have f of negative 10. Well, I go to negative 10 and say, all right, is negative 10 between negative 5 and negative 1? No. Is it between negative 1 and 3? No. Is it greater than 3? No. It was a no for all of that. And so because negative 10 is not existing in this function, that means it's just undefined here. And that is everything you need to know for 6.3.